Alright, this is another example of integration by parts. And in this example we're going to try and find the integral of e to the x cosine of x dx. First thing we need to do is assign our u and du, or u and dv I mean. So u, in this case I'm going to let it to be equal to cosine of x. That makes du equal to negative sine of x dx. And v is equal to the integral of dv, which we're going to choose to be equal to e to the x. And that makes the integral just e to the x again. Now, if we write our integral out, we have uv, or we'll write it in the other order, e to the x cosine of x, minus, and this minus sign here is going to cancel out, the integral of v du, so e to the x sine x dx. We already took care of the negative sign right there. And this is another function where we have to use integration by parts, so we just use it again. But in this case, u, du, v, and dv. We'll choose dv to be e to the x again. V is still equal to e to the x because it's the integral. This time we're going to choose u to be sine of x, and that makes dx cosine x dx. And then we write out our integration by parts. So let's put a little jiggle here. So we have plus, this term is uv again, so e to the x sine of x, plus, I'm sorry, it's actually minus the integral, I'll fix it, minus the integral of v du, so e to the x cosine of x dx. And if you notice, we have the same thing here as we do on this other side of the equation, so we can add them back together. 2 integral e to the x cosine of x is equal to e to the x cosine x plus e to the x sine x plus our leftover constant c from this improper or indefinite integral. If we divide by 2 again, then we'll have the integral of e to the x cosine of x is equal to 1/2 e to the x that we factor out cosine of x plus sine of x plus c. And that is the answer, or the integral of e to the x cosine x dx is equal to 1/2 e to the x cosine of x plus sine of x plus c. Thank you.